Hello everyone. In this video we're going to be solving a differential equation. We have y prime equals y over x plus 2 times the square root of y over x. And we're going to be solving for the y values. So to simplify things a little bit, we can assume that x and y are positive, so that y over x is always going to be positive. But if x and y are both negative, then you can slightly modify the solution to fit the requirement. So let's go ahead and solve this equation by using a different variable for y over x. So let's go ahead and set y over x equal to u, and then from here we're going to get y prime equals u plus 2 times the square root of u. Now obviously this assumption means something, so that we can evaluate y prime from here. So let's go ahead and write it down. Y over x equals u, and obviously x does not equal 0. Multiply both sides by x, we get y equals ux. Now we can differentiate both sides. Notice that u is a function of x, and we can use the product rule. Y prime is the derivative of u multiplied by x plus the derivative of x, which is 1, multiplied by u. So we can write y prime as x times u prime plus u. So that's something we are going to substitute into our equation here, and then everything will be expressed in terms of x and u. We'll get rid of y for the time being. So let's go ahead and replace y prime with x u prime plus u, and that should equal u plus 2 times square root of u. U is going to cancel out, which is nice. From here we get something like this. X u prime equals 2 times the square root of u. Let's go ahead and write u prime as du over dx. Remember, I had already told you u is a function of x, so u prime can also be written as du over dx, which means the derivative of u with respect to x. And that equals 2 times the square root of u. Now we're going to keep the 2 and the square root of 2 together because it's better that way. And let's go ahead and divide both sides by 2 times the square root of u, so that we can put all the u's on the left hand side, and let's put the x's on the right hand side. So we have dx over x. Now at this point we can go ahead and integrate both sides with respect to x, and remember u is a function of x. So now what is the integral of 1 over x? It's ln. What about the integral of 1 over 2 times the square root of u? And that is equal to the square root of u. Now if you don't see that right away, you could do the following. So an alternative, you could write this as 1/2 times u to the power negative 1/2 du, because 1 over square root of u can be written this way. 1/2, I put it outside because it's a constant, so we can pull it out. Now using the power rule for integrals, remember you're supposed to increase the power by 1 as long as it's not negative 1. This rule is going to work, and then divide by that number. So if you add 1 to negative 1/2, it's going to become positive 1/2, and then you're supposed to divide by 1/2. And of course there's a plus c, but we don't have to worry about it right now. And then the 1/2 is going to cancel out, leaving us with u to the power 1/2, which is the same thing as square root of u. That's why if you integrate 1 over 2 times the square root of u, you get square root of u. Or we can put it this way too. If you differentiate square root of x, then you're going to get 1 over 2 times the square root of x. Or if it's u in this case, like the derivative, u is a function, then you're going to get u prime divided by 2 times the square root of u. U prime is there because of the chain rule. Okay, great. So to keep a long story short, I know I've taken too long to explain this, but I want to make sure everything is clear and I'm not rushing. So the integral of 1 over 2 times the square root of u can be written as simply square root of u. And if you integrate dx over x, that's going to give you ln x plus c. As I said earlier, we're going to assume that x is positive, so we don't need absolute value. But if x is negative, you can use absolute value and then proceed that way. Now, it would make sense if we square both sides, because our goal is to get to y, and that can be through u. So square both sides, and we're going to get u equals ln x plus c quantity squared. Awesome. So that gives us the value of u, but we have to go back to y because we're trying to solve for y here. And the relationship between x and y is what? Y over x equals u. So now we can go ahead and use this. Y over x equals u. Therefore, we can kind of replace u with y over x. And then from here, since we're trying to solve for y, I don't know why this is happening with Desmos sometimes. It's really weird. I mean Notability, I should say, not with Desmos. Anyways, so since we're trying to solve for y here, let's multiply both sides by x. And that's going to give us y equals x times, that's kind of weird. I don't know why. X times ln x plus c quantity squared. And that should pretty much give us all the solutions. You know, if there are any other solutions that I'm missing, please let me know. I'm probably missing something, but anyways, this should give us the solutions. And obviously for different values of c, we get a different function. So this is kind of like a family of functions. And we have some problems that are called initial value problems, where if the function is evaluated at a certain point, or sometimes its derivative is given, such as they can give us something like, okay, suppose y 1 equals 5, or f of 1 equals 5, which is the same thing. And then you can basically evaluate this, plug it in to find the constant, and then once the constant is determined, then you do have a specific solution as opposed to a more general solution. All right, and this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.